we did a more basic one that just had x minus h squared, we didn't have any number in front, we didn't have any number being added or subtracted. And we just kind of messed around with this one, and we saw that when we have x minus a number, for example 5, it's going to move it 5 spaces to the right. By it, I mean the actual whole parabola. So every point on the parent function moves 5 points to the right. When it's x plus 1 squared, for example, it's going to move left. So again, starting at that parent function, we're moving left 1 space, and so every single point on there is going to be moving 1 space. We're going to add on to these different movements today. Today's lesson is 8.4 day 2, vertex form, reflections, and vertical stretch and shrinks. We're going to be working on graphing these and also describing the functions when it's in this vertex form. So we talked about this the other day, our vertex form. And so we're going to see that there's a number A, and we're going to see that there's a number K. All right? And we'll see what those two movements do. Because this H is always going to move it left and right. Think horizon. Okay? We've talked about the vertex. Just kind of a quick reminder when we're dealing with a parabola. Your vertex is that very low point if it's a U shape. If it's an upside down U shape, it's that very high point. So our vertex will actually be given with our H and K values. So if this is 1 and this is 2, well, then it's going to be 1, 2 as our vertex. Axis of symmetry is always our x value, is always our x value in our vertex. Those guys will always match up. Okay? So let's check out, don't want that. Let's check out some transformations. I'm going to go ahead, and since we already talked about our H, I'm going to find our H transformation here. So let's go down right here, kind of the 2 up from the bottom, okay? This guy here is going to be moving it. Moves points right. Okay, this is gonna move points left. Okay, that's the plus does it, the minus moves it right. Okay, and then that'll move it right, and then if H is 5, it'll move it right 5. If H is 2, it'll move it right 2. It works the same with our left movement as well. Oops, I didn't mean to erase that. Sorry. So let's check out, and we're going to graph some and see what some other transformations. So we're going to be bouncing back and forth to this main kind of cheat sheet that we're going to create. But I want to see what these other movements do. I don't want to just tell you. So let's turn the page, and we're going to find that A value when it's less than 1, because 1/2, right? So when our A value right here is between 0 and 1, the absolute value. I don't care if it's positive or negative. This is going to vertically shrink. If you want to say compress, that's fine. Vertical shrink, vertical compression. Okay. Big Ideas uses shrink. I've learned it as compression. I don't mind. I'll take either one. Okay. If this is a vertical shrink, then think about if it was bigger than 1. What would that be called? Good. Vertical stretch. Okay. So let's pop over here. That's this one right here. This negative in the front reflects over x axis. Okay. Now, new pieces, our last pieces to our transformation. So flipping back to page 104. This k at the end, if we have a plus k at the end, it's moving it up. Move points up. Well, then opposite of that would be to move points down. Okay, for now. And we're going to check this out here. Okay. So we have g of x, that's our function, is equal to 1/2 x squared. They want us to graph and describe the transformation. This is just kind of a reminder how it changes, okay, from the original parent function. Remember, the original parent function is always this fx equals x squared, and that always gives us these points. We could have 3, 2, 1, 0, -1. Oop, not big enough. Hold on. I'll write smaller. 3, 2, 1, 0, -1, -2, -3, and there's more. If those are my x values, then my y values are just found by plugging in the x value for the x and squaring it. So 3 squared is 9. 2 squared is 4. 1 squared is 1. 0 squared is 0. And then the negative versions are also just positive because, remember, squared means times itself. So -1 squared is -1 times -1, which is +1. -2 times -2, +4. -3 times -3, +9. Now, my graph here only goes to 6 and -6, so I won't be able to graph my 3's, but we'll go ahead and graph the -2, 4, the -1, 1, the 0, 0, +1, 1, and +2, 4. And we'll make that dashed. And we're going to label it f of x, okay? That's always our parent function. That's what every function for quadratics starts out as, and then we have these transformations that happen. So I can already say this is different because this has a 1/2 in front of the x squared. So let's go ahead and make a table of values, and we'll kind of try and do the same thing. We could do, 3 wasn't too big. We could do 2, okay? We'll do 1, we'll do 0, we'll do -1, we'll do -2. And we've even talked about these before. When you have a fraction in front of this, we've actually discussed this a little bit. I like to sometimes pick x values that are multiples of that number to make it easy on myself. Denominator. And you'll see in a moment my 1 is not a multiple. It gives me a fraction. Not impossible to graph, but it just makes it a little bit more difficult. So if you want to avoid any decimals or fractions in your y input, you can try and avoid it by just picking multiples of the denominator. So 2, 4, 6, 8, any of those would work, okay? 1 works just fine as well. So we're going to take our 1/2. Instead of an x squared, we're going to put parentheses, and inside there, we're putting our 2, because that was our input. Order of operations says we have to square first before we multiply by the 1/2. And then when we multiply 1/2 and 4, we get 2. Okay, because multiplying by the 1/2 is just like dividing by 2. So that gives me the point to graph. I have my x value of 2 and my y value of 2. So that's the point. 2, 2, +2, +2, right there, okay? And then we're going to do the same thing for 1. 1/2 times 1 squared, well, that gives me 1/2 times 1, which is 1/2. Not impossible to graph, okay? 1/2 just means I'm going halfway. So I'm going to go +1 and then 1/2. Okay, so right there. If I do my 0, 1/2 times 0 squared, well, 0 squared is 0, and anything times 0 is still 0. So that gives me the point 0, 0. Oops. There we go. So they share the point on the origin, and that's totally fine. Let's do our -1 and our -2. Same thing. When you have an even power, that -1 times itself becomes a +1, and 1/2 times +1 is +1/2. And then the one down here, -2 squared gives us a +4, and multiplying by 1/2 gives us +2. So I get my last 2 points, -1, +1/2, -2, +2. And you'll see when we do that, -1, +1/2, -2, +2, it matches points on both sides. okay? Now, the transformation is, how do I go from blue to red? So we see that the blue to red, the red got wider, okay? This graph is definitely wider, okay? Mathematically, what that means is that you have this vertical shrink. Sometimes this is called a compression. And we have to always tell them by how much. The by is actually just the factor that was in front. So we're going to say it was a vertical shrink by 1/2. That is your transformation. So anytime you see a wider graph, it's always going to match this vertical shrink or compression. So let's pop back. Let's check it out, okay? Let's pop over, we'll go to number 2, okay? Number 2 just has this negative. Now, there's no parenthesis in this to start with, okay? When I pick my numbers, pick -2, for example, I have to write my negative sign. I have to write my parenthesis for where my x is, and I have to write my square. You cannot forget the negative and the power of 2, okay? Can't just leave the negative off because we're going to be plugging in with a negative. You have to do both, okay? It's very important you don't leave that off. So I have to do my power of 2 first, which means that negative on the outside is still there, okay? -2 squared means -2 times -2. 2 negatives are going to give us a positive, so I write 4. Because I couldn't get rid of that negative on the outside, it's going to be -4. So I have 2, -4 as my point. Oop, before I forget, let's do that parent function again. Or just copying those points that we already found from the parent function. I find it's a little easier when it's right on the same graph to compare to see if it got bigger or smaller, moved left, moved right, shrunk, stretched, flipped over, okay? So -2, -4, we got a point down there. Perfect. Okay, let's do -1. If we have a negative, and I do -1 squared, okay, I still have that negative on the outside, and now I have that 1. So I have a -1, -1. 0, negative, parentheses, 0 squared. Well, 0 can't be negative, so 0 is just 0. +1, oops, and +2 work the same way. +1, +2. Okay. This guy now flipped, okay? That's what we're seeing visually. Mathematically, what it's doing is reflecting over the x-axis. We've talked about that transformation before as well. Last one we're going to be doing. Before we forget, let's do our parent function, 0.00, -1, 1, 1, 1, 2, 4, and -2, 4. Dot it or dash it. And I'm going to label it. Okay. So now I have 2, then an x, then a squared. So I'm going to stick with my basic, -2, -1, 0, 1, and 2. That's my inputs. Remember, I can input anything into quadratics. My domain is all real numbers, so it's literally any x value I want. I don't want to go too big because that square will get big fast. It's exponential. So I try and stick to just the smaller inside ones. A little bit easier to manage. So -2 is going in the inside. And we're going to do that with each of them. So go ahead, and I'll kind of work silently. Go ahead and do this. If you need help, just look up at the screen. Notice my 2 is in the same spot. My power of 2 is in the same spot. I have put a parenthesis for my x value. Now I'm just going to fill in. Remember, order of operations, do your powers of 2 first. So multiply these red numbers, okay, by itself, and then multiply it by 2. We have our x values here. We have our y values here. So we're going to go ahead and graph those. 8's too big. I can't fit on my graph, so I'm going to go to -1, +2. I guess I could go negative or +8 up here. I'll do that. -2, +8. 0, 0, 1, 2, and then 2, +8. Kind of all the way up there off our graph. And I know as it gets skinnier, it's kind of harder to make it a U shape, but do your best because V shapes are absolute values. Those are different functions. Okay. So this guy, visually what happened here, from the blue to the red, it got thinner or skinnier, okay? That's what we visually see. Mathematically, it's a vertical stretch by 2, okay? This number in front will always match this guy, okay? Vertical stretch and shrinks are always positive numbers. If you happen to have a negative, that is an added transformation that happens, which is reflect over the x-axis. With, for example, this guy, okay? We didn't have anything being added inside with my x or subtracted or anything added or subtracted on the outside. So that means that it's almost as if I wanted to put something here, I'd say -0 squared plus 0, right? Technically, technically I could write this and it still equals the same. So this is also still in vertex form. If you are missing any addition or subtraction, your vertex is 0, 0. And that's why those vertices are on 0, 0 every time. It's still in vertex form. You just don't see it because we don't write -0. We don't write +0. So this next one, you'll see we have a negative happening and we have a 3 in front. So we have 2 things that are going to be changing here. So let's see what happens. 3 is a whole number, so I don't have to worry about picking a multiple of it. I'll just stick with my small ones. We'll just do -1, 0, +1. Because multiplying by 3 after we square, it's going to get big fast. So I have my negative sign. I have my 3, parentheses where my x is supposed to go. Have my -3, parentheses, squared. -3, parentheses, squared. Okay? My x value is what we're putting inside those parentheses. So I have -1, I have 0, +1. Order of operations, make sure you do your power 2 first. So -3 times 1. -3 times 0. -3 times 1. This gives me -3, 0, -3. So there's my y values for my points. Oops. So I have -1, -3. Oh, before I forget, I almost forgot my parent function again. Let's get that guy on there. We don't have to do it after. Okay. -1, -3 down here. 0, 0. And +1, -3. It is a U shape, so make it U-y looking. Okay, now, this guy not only flipped, but if you look closely, it got skinnier. If I were to flip this up at top here, you can see my blue is wider, okay? Which means that my graph got skinnier. So it flipped upside down, it got skinnier. Mathematically, we're going to write the transformations. So this negative, if there's ever a negative, It's reflect over x-axis. Okay? And there's the 3. That made it skinnier, which is a vertical stretch by 3. So you have to have both of those transformations separate. I do not say vertical stretch by a -3. You got to make sure that that stays positive. Vertical stretch, vertical shrinks are always by a positive number. The negative, you have to write reflect over x-axis for that guy, and then you can't use them again. All right, so all of those were monomials, okay? Meaning we didn't have anything being added or subtracted or anything like that. So I was kind of at the mercy of having to do my table. Yesterday, when we did our horizontal movement, we talked about that vertex form being really handy and telling us where the vertex was. So I'm going to show you guys how to use that for these next ones. Oh, and I kind of recounted here. So we don't have to flip back and forth. I'm going to write the vertex form up here. Y equals a times x minus h squared plus k. All right. This is called vertex form because these two pieces make the vertex. The vertex is always a point that's the highest point or lowest point of the graph. All right. So I can see that 2 and 3, right? Now, this is supposed to be a minus. The only way this would become a plus is if this 2 was originally a -2, okay? So you kind of have to think about that. The h is kind of weird where it doesn't really follow the same sign. So when I write my vertex, I have to make sure I write -2, comma 3. Because the h is actually a -2 that was plugged in. It only turned positive because there was 2 negatives right there. So that's going to be my vertex. Let's go ahead and put a point on our graph at -2, +3. Okay, there's my vertex. I almost forgot to put my parent function again. Point. I'm going to do it in blue and do dashed. Okay, that's where my parent function, try not to cut the word vertex, originally was. Okay, now, there's a couple different methods after you find the vertex on how you can find the rest of the points. So I'm going to show you both ways. Since we've been kind of using the table, I'll show you the table way first. If I know that my vertex is -2, 3, right? I'm going to pick a number smaller than -2, and I'm going to pick a number bigger than -2. So I picked -3 is smaller, -1 is bigger. And I'm going to do my calculation with -3 as my input for my first one. I still have the +2, I still have the squared, I still have the +3. Remember, I'm just copying the original function here. I replaced x with -3. I kept everything else the same and in the same order. You cannot switch things around. You can't make the multiplication. I'm going to do it for my -1 down here as well. And then order of operations, I have to do inside my parentheses first before I square it, and then I can add. Do my parentheses, square it, then add. Okay? So we have -1 squared +3. Well, that gives me +1 +3, and that gives me 4. So I have a point at -3, +4. Okay? And then I do the same thing for my -1 down here. That gives me 1 squared +3. 1 squared is 1, +3 is 4. So I get the point -1, +4. There's my g of x. So that was one way. We found our vertex, we picked a number smaller, a number bigger, and calculated using our table, just like we've done with the other ones by doing those points. And so we found a point -3, 4, and -1, 4. Your other way, because we're going to have to describe the movement anyways, is to describe the movement first. So if I have a +2 here, we talked about that yesterday. That +2 is moving it to the left 2 spaces. And the +3, we can now see it. +3 moved my vertex up 3. So this is my transformation. That's what every single point in the parent function does. So watch. Here's my vertex down here. Vertex. And my new one was up here. So I could see I had to go 1, 2, 3 up, 1, 2 to the left. So I would do the same thing with this point. 1, 2, 3 up, 2 to the left. This point too. 1, 2, 3 up, 1, 2. These guys I would also move, but they go off my graph. That's why I didn't graph them. 1, 2, 3 over 2. Okay? So there's our 2 A's, and we have 2. Nice. Let's try this next one. Okay? So I'm going to take my vertex. Okay? This is going to be +1, +2. That's the vertex from our form. I'm going to go ahead and put my parent function. And I'm going to go ahead and put my vertex. 1, 2. Okay. So this was my starting vertex. This is my new vertex. So I'm going to do it the other way. I'm going to not do my table first. I'm going to try and see if I can figure it out just by seeing how my vertex moved. So here's where I started. Here's where I went. So I had to go up 2, right 1. And that's exactly what these numbers are telling me. Up 2, right 1. Up 2, right 1. And those are the transformations. So now I'm just going to do that with every point. I'm going to, oops. There we go. I already moved my vertex, so I'm going to move this one. Up 2, right 1. This next one. Up 2, right 1. These guys. Up 2, right 1. Up 2, right 1. And there's our g of x. So I didn't have to do any table with this. I still could if I wanted to. Again, I would just use my vertex as my starting point, and I would pick one smaller than 1 and one bigger than 1. And then I would do my calculations. Real quick. Let's do these last two, okay? Before I forget, because I seem to keep forgetting my parent function, let's go ahead and just sketch in our parent function real quick on both of them. Okay. Vertex form, I can tell because there's parentheses. It looks just like this guy with parentheses with a power, and I have numbers, right? So here's my vertex. I have +4, -2. I'll do this one as well. This one started out as +3, so it's -3. The other one's -4. Again, that H is a little tricky. It likes to change signs. So just be careful. Everything else, the sign doesn't change or mess with you. So what these mean is that we're moving to the right 4, and we're going down 2. That's our transformation. Okay, so let's go ahead and move our vertex. We have +4, -2. And so I'm going to move every point. Right 4, 1, 2, 3, 4, down 2. 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 Okay, and so you can see our whole graph has now gone to the right 4 and down 2. Let's do one more using our little cheat code. Okay, so we have our vertex. That vertex is telling me I'm moving to the left 3. Oops, that's a weird 3. 3, and I'm going down 4. Okay, so every single point is doing that. -3, -4. So we're going 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. Okay. Now, I'm going to have you guys hop on Magic School and do a quick learning reflection. Just dump as much information in there as you can think of. And then you do have a paper homework to work on today. And I will see you tomorrow.